Hello, and welcome to the next video in this series, Griscom et al. And land use land cover change using MODIS and dynamic world imagery. Um, in the last video, we were able to get to about this point in the analysis on both these slides for Indonesia and Mozambique, in that we were able to use the Python scripts to be able to derive the deforestation rates, the current land cover, and also the aggregate statistics around deforestation rates, so the average annual 10-year and 5-year statistics. In this video, we're going to do two things. One is get the biomass density from a few sources. One is from NASA Oak Ridge National Lab. We get above and below ground biomass density, and from a data set from a company called Envirometrics, we'll get soil organic carbon to be able to build an estimate of total biomass density per hectare for that region. We'll also corroborate this estimate using Global Forest Watch data. Like we explored it, this I thought this data was outdated, but actually it's recently been refreshed. So we're going to be looking at some better and newer data to work with to get the total carbon biomass density estimate. And using that, we'll then, and with our awareness of what the reforestation potential is, or using some kind of meaningful guess or educated guess, we will try to compute what is the total tonnage we can estimate from this reforestation activity. So we're going to complete this for both Indonesia and Mozambique, and in the next video we'll replicate this deforestation rate percentages using dynamic world imagery. So we're almost at the end of this. Let's get going. So the first thing is we're on this Python notebook now, and we want to, we've executed a bunch of things in the previous video, and now we want to go ahead and evaluate our kind of set to the output folder, NASA Oak Ridge National Lab above and below ground biomass density for all the shapefiles in our list. So I'm just checking the code that we have absolutely everything here set up and ready to go. We're going to run it for all the shapes in that list. So I think this looks pretty good to go. So if you notice, the above and below ground biomass statistics is between 2010 January and 2010 December. I just want to make sure that we don't have any newer data than that. So I'm going to search for NASA Oak Ridge National Lab above ground biomass, below ground biomass, Google Earth Engine, because I'm getting it from Google Earth Engine. This is the data set we're looking at. And yeah, it's only available for 2010. And this, like I mentioned, this was an average estimate between 1950 and or 19. It was like a very, very long term average, if I remember right. So we're going to compute that long term average. I'm just looking at the basis. No, that was Environmetrics. Oak Ridge National Lab estimated only as of 2010. It was the soil organic carbon estimate that was the 1950 to 2017 average. So anyway, we're in a position to go and run this cell because it's going to generate all the files to the output folder. Similarly, the next cell is actually trying to look within the outputs we generate and then give us an estimate that we can just bring into the slide for above and below ground biomass density. So it'll give a mean and a standard deviation. Yeah, I think we're in a position to run this, so we can run this cell. So it'll start producing the statistics for each of these. We already entered our API key in the last video, so we don't need to validate this app. It'll do its job. I can see that it's outputting the results to the right folder as well. So we're in a good place. just working on last piece. And it's completed. So great. So now we just need to go ahead and generate these aggregates and put them into our slides. So if you remember, I had maintained a number here called COL for column, um, only in case I really wanted to look within at a polygon level. So assuming I had a region of interest and within that I had three polygons, if I wanted to look at the statistics that was generated for each of the polygons, I could vary the COL number and that would go and only bring about the results for that column. But this is not something I really need. I don't necessarily need to view the results at a per column level because I'm only at best interested in Benakat at the level of the forest of Benakat or Sabanjariji. So I'm just going to go ahead and replace these with mean so that we get to see only the average estimates here, like we did even in the case of deforestation rates or current land cover. So I run this for the first polygon here. I get the values for Mozambique. So I can copy this in to the slide. So first I'll go ahead and put one of these boxes in our slide so that we can start filling it out. Okay, great. Here we are. Yeah, or I'll just move that to the bottom. Yeah, that's great. So we can start filling it out. So we're working with Mozambique now. So the above ground biomass, it says on average is 30 tons per hectare with a standard deviation of about 8 tons per hectare. That's what the data is telling us. I mean, we'll obviously have other ways to validate whether what the data says is right. Again, remember, this is as of 2010, and now it's been 13 years since the forest could be significantly more mature and could really yield a much, much larger biomass density. Uh, so that's fine. Let's go and create one of these boxes again here for Indonesia. If you've kind of run out of space on the slide, let's go here and I'm going to create three columns here, column to the right and again column to the right. So we have up here, and there we do, and and here again you can just go replace it with Reserva Recreativa. Okay. So now we can do the same thing we did for Mozambique for Indonesia. Or wait a minute, did we get below ground biomass for Mozambique? I don't think we did. So let's go put in the estimate of below ground biomass just in case we didn't. Now we have it for sure. Okay, let's go and run the next one, which is for Benakat. Look at that, it's yielding 70 tons per hectare, standard deviation of 16. So it's more mature forest by the looks, which is good for us. Doing reforestation activity there will lead potentially yield a greater biomass density. Okay, let's copy the below ground biomass density as well. Now let's run this for Subandariji. Again, a really healthy average level there for above ground biomass and also for below ground biomass. Now let's run this for Pura. Not nearly as mature a forest here. We only get 20 tons per hectare, 19.9. Let's we have our estimates in here. The next piece that we actually do want to calculate here is to replicate, generate those output files for the soil organic carbon source from Envirometrics Open Land Soil Organic Carbon dataset. Just checking the code that we run it for everything. Looks like it's meaningfully set up, so we can just run that and it'll do its job and bring in all the files to our output folder. And then we can look and analyze those files. It's moving really, really fast because it's not as big a data set to work with. There are probably fewer points, or it's probably summary statistics that are not as dense as the other data set. And it's also computing only one source, which is soil organic carbon and not above and below ground biomass. So it has only one data point to evaluate. Okay, so it's complete. It's completed running, and now we can look at it. Similarly, I had this column argument here to be able to look at it at a polygon level. We don't really need that, so I'm going to go and replace those here with mean. We only get the averages, and then we can start by looking at Mozambique, and we have an estimate here, which is great. So we can bring those into our Mozambique slide. So the first estimate is for soil organic carbon at a 1 meter depth, and the next estimate is soil organic carbon level at a 2 meter depth. These are useful estimates to study the soil composition and the ag soil carbon or the soil carbon level as you go deeper into the surface. It's again an indicator of how mature the forest is. So we have that for Mozambique. Now we're going to get that for Penakat. You can clearly see the values are much higher, as is the standard deviation. Obviously, the error being higher is not a good sign. And that really just goes to, if the error is high, it just goes to show that it's possible that one of the polygons is an outlier. Could be distorted by outliers. Not looking at that level just yet. We'll be able to look for these with much more high-res data in the context of Indonesia later. So we don't want to optimize at this point, which is great. So now we look at the next one, which is Banjariji, and we bring that into the slide as well. Okay. And finally, we run this for Martapura forest, and we bring that into the slide here. Right. So the last few rows here are sourcing similarly woody biomass density from Global Forest Watch. So we want to go and get these estimates from Global Forest Watch. So here I am on Global Forest Watch. I remember loading it up last time. I have a indicator of biomass density and soil organic carbon. We only want to get live woody biomass and soil organic carbon here. So now we can start searching for our region of interest. Right? We know we want to look at Kovuro area in Mozambique in order to estimate for our Reserva Recreativa. So I want to analyze this region specifically. I could go one or two levels deeper, even within Govuro if I zoomed in, perhaps. It may allow for it. If it has boundaries, uh, Global Forest Watch may allow for it, or it may not. So, but that's okay. So let's just look at Govuro statistics it's generating here. Unfortunately, this doesn't look like it has much more updated data than 2000 actually for Mozambique. So the updated data we saw elsewhere was for elsewhere, not for Mozambique. So anyway, we here are our estimates here. We have our estimates here. So we can just copy that in here. Yeah, so for Govuro, we're going to use Govuro as a proxy for Reserva Creativa. So I will just go ahead and yeah, so basically we have this estimate here is 78.2 tons per hectare. The formula is not correct. So I'll just make sure that I highlight that I used Kovura as a proxy. And then I will also get the soil organic carbon, which is 51.6 tons per hectare. So I will put that in 51.6. So, and below that, we just need to sum up that 78.2 plus 51.6 is 129.8. 129.8. Typically, you know, mature forest can yield between 150 to 200 tons per hectares, and we know this is slightly old data to 2000. So we're going to assume that it's slightly more mature and yields 150 tons per hectare. So that I've set up a normalized estimate just in case I want to override that number of 129.8. So if I were to normalize it based on the assumptions I just told you about, I would try to set it at 150. But let's see closer to the point of estimate whether we want to consider the actual estimate or the normalized estimate. Nevertheless, I leave it in there. So that's how we complete this table for Mozambique. Now let's go ahead and do it for Indonesia. Here we are. So now we want to try to get to our next region of interest. I'm going to search for Banakat to see if it's actually available. It's not available there, and I want to search for Subanjeriji. Here may not be available, and Martapura is not available. So we are going to have to make some hacks here. Let's just load up maps. I want to see what we can use as a proxy. So let's first go into South Sumatra, Indonesia. It's a very, very large area, like you see, and at least we want to be able to use three different parts. We know that Mart. We know that Benakat is to the top left here, to the northwest. We know that Subanjariji is somewhere in the center, and we know that Martapura somewhere to the southeast of this area in South Sumatra. So we're going to use that to our advantage. Let's see what this is. Rambang Niru. Let's see what this is. Merapi Timor. And let's see here. Peninhaunan are the provinces. So I'm going to use these as proxies, which I think we will find. So let's search here instead for Rambang Niru. It's possible that I find it. Okay. Let's just go straight here into South Sumatra as well. Sumatra. Oh, unbelievable. That's good for Indonesia. So Global Forest Watch does not have really good detail in the context of Indonesia by the looks. Not to worry, we'll go and find it. So let's just get down there here to where we want to go. Right. We are here and we don't have too much detail by the looks. No, we do. Yep, we have the detail that we need, which is great. We can see it as at the provincial level, but we want to make sure we get the right provinces. Batanghari, Jambi, Musi, Banyuasin. Okay, great. This is the time to look at what we want. Bangunsari. Yep. Samangus. And Penin Chaunan. Okay, let's look for Penyantikan. Okay. I think a better way to do it is to actually use this map to our advantage that we have here. Put in a Google Maps base map and try to really zoom in from within this area to see what we can use as a proxy. Bear with me because this takes a bit of work to find where we want to go. Interesting. Sobanjariti, that's how they spell it locally. Simpang Teras Camp. I'm just looking out for local landmark. Local landmark. So here I think for Benakat I want to use Talang Muara Sungai Bunu. So let's go. Sungai Penu. I think it should be slightly lower. Jambi. I think it is in the region of Jambi. Jambi. Sarolangun. Rangin. Jambi. Alright, since it's such a large area, I'm just going to use the entirety of Jambi as the proxy for Benakat. I think that's fine to use. It's a large area and we can take the average. Yeah, that's fine to do that. So here, as you can see, the woody biomass density is so high, 233. It's an extremely mature area. So here, 233 tons per hectare. So I'm going to highlight that I'm using Jambi as the proxy there. And also let's look at the soil organic carbon here, which is 2.5 kilotons per hectare, and that seems extremely large. It's really possible that's a really poor estimate, but nevertheless, we just have to put that in there. So I'm just gonna meaningfully probably leave the soil organic carbon here. I'm gonna normalize that to 200 because 233 seems too aggressive to consider for any kind of estimation model, like for potential, like we do even before we've explored the project on the ground. So I think uh, these are the numbers I'm going to be running with for this. Um, let's look at Subanjariji. I think for that I want to consider this whole area Sumatra Selatan. I think that's that's too large again. Musi Rawas. I think I'm going to run with Musi Banyuasin because I think that's where the Subanjariji forest is. Musi Banyuasin has 176 tons per hectare above ground biomass. It's plausible that this number is correct. I'm nevertheless highlighting that I'm using Musi Banyuasin as the proxy. Let's look at below ground biomass, 266 tons per hectare. Soil organic carbon. So I'm just gonna put 176 here, and I'll round that down to 150 probably. And we know that Martapura is somewhere in the southeast of this graph, of this map. So thinking of using Prabhu Moli or Pung. Let's look at Sumatra Selatan. How big is that area? That's just too big. Nah, that's just all of South Sumatra average would be too big to consider. I think for Martapura, I'm going to run with Prabhu Moli, which seems a little bit small. Probably not what I want to consider actually. Let's see. Martapura is near Kotobumi. I think that's a better place to consider. So let's go to Kotobumi actually, which is much lower here.